Hello everyone. Let us discuss about derivation of the gradient descent rule in this session. So we already seen that gradient descent is nothing but performing a partial derivative on the error with respect to the weight vector W, right? So why we need to do is to calculate the direction of the steepest descent along the error surface. Okay? So this vector derivative we are calling as gradient of E with respect to W, and we can write it as delta EW. So here W is the weight vector. So we are mentioning this arrow to say that it is a weight vector. Okay. So this weight vector we can represent it as partial derivative of error with respect to various weights, W0, W1, W2, so on up to Wn. So this is how we can represent delta EW, which is the gradient of E. So now, similar to the perceptron training rule, whenever we want to update the weight, what we do? So to the actual weight, we will be adding up this error value, right? So that is, whenever you want to update the weight, Wi is Wi plus this delta Wi, whatever we are obtaining. Okay, so here this delta W is a vector. Okay, so let us write it as delta Wi. So where this delta W, we can write it as so the delta W is minus eta delta E of W. So here this eta is the learning rate. So here you can see we are taking a negative sign. The reason is we want gradient descent. If you are taking a positive sign, so this will give us the gradient ascent value. But I want a minimization problem and I want gradient descent. So only we are taking a minus sign to know the steepest descent. So now, if you substitute this back in the original formula, and if you generalize this, we can write delta Wi as Wi can be written as Wi minus eta delta E of W. So here once again, what is this E of W? So if you write this in general form, how can we rewrite this one? So we can write it as dou E by dou W I, right? So where you can substitute value for I from 0 to n. So I can rewrite this as Wi is equals to Wi minus eta dou E by dou W I. Okay, so now let us see how we can derive this one, dou E by dou Wi. So we already know what is the error value. So error we have taken as half sigma T minus O whole square, right? So this is the error value. So now this I have to perform a partial derivative on this with respect to W. So that means I want to perform dou E by dou W. So where E is my half sigma T minus O whole square. Or we can also write it as TV minus OD whole square, which should be derived with respect to the weight vector, that is W. Let's see the derivation of this. So this is the error term that we have, and this we want to perform derivative with respect to Wi. So if you remember, the derivative of x square is 2x. So let us take this constant outside and just rewrite this. So it is half dou by dou Wi sigma TD minus OD whole square. Right? So this whole term, let us treat it as x square. So I should write it as 2x. And again, I should perform a partial derivative on this x, right? So let us perform the same thing here. So it is half dou by dou wi. So this 2 comes to the front. So it is 2 into TD minus OD. And then again we perform a partial derivative on TD minus OD. And once again here, what is our output? We have expressed our output function as W bar into X bar. So multiplication of vector W with the input X, right? So let us substitute the same value here in place of OD. So this I can rewrite it as dou Wi TD minus W X. So here we are taking the value of output. We are just substituting the formula of. So here it is OD. So let us write it as XD. Okay. And here it is instance I. So I'm writing it as Wi XID. So now TD is a constant value. So that means we are performing derivative with respect to W. There is no W term here. So this value becomes 0. And we will be applying only derivative here. So derivative on W. So this Wi value will become 1. And finally, we will be obtaining minus Xi. Rest of the value is as it is. So that is half. So this dou we already applied. Half into 2 multiplied with TD minus 40 multiplied with XID. This 2 and 2 gets cancelled. And finally, what we have obtained is dou E by dou Wi is equals to TD minus OD multiplied with minus Xi. And here we have the summation also. So let me write the summation here. So this is the value of dou E by dou Wi. So what is my delta Wi? Delta Wi is minus eta dou E by dou Wi, right? So let us substitute that here. So final formula for delta Wi, what we will be obtaining is minus eta into sigma X is ranging from D to D, TD minus OD, and a minus XID is there. So minus and minus will become plus. So let us take it as a plus value, and here I am writing XI. So this is the final equation of delta Wi, what we have obtained. So this we will be adding to the original weight vector when more updating the weight. So that is Wi is equals to Wi plus delta W. So in place of this delta Wi, we will be adding this whole value. We will compute this value and we will add it there. So this is how a particular weight gets modified with respect to the input value. Okay, hope you followed this video. If you have any queries, please let me know in the chat section. And also if you need any other topic to be discussed early, so please let me know in the comment section. Also, thank you for bearing with my voice. Recently, I'm struggling with cold and cough, so my voice is little sore. So please bear with that. And I want to thank all my subscribers who are watching my videos continuously and supporting me. Thank you. See you in next video.